How to design a structure in STAAD Pro. First, go to new model and type your project name like G+4 building. Select unit, metric and model type analytical model. It is optional, and then create. First, click for one node, click 0 and press enter. It is my first node and the location of this node is 0, 0, 0, x direction in y direction and z direction coordinate. Okay, now go to select, first click window and then go to select and click node, select node and click Ctrl+C and then Ctrl+B. Okay, you can copy, otherwise cancel and go to geometry and go to translation repeat. Okay, first we have select nodes and go to translation repeat. We will translate in x direction. Okay, so global direction will be x and default step spacing will be 4 meter. We will take 4 meter. Okay, and number of step is 5. Okay, so number of step is 5 and click link steps because we will create our beams. Okay, so click link step and default setup spacing and number of steps and now click OK. You can see we have 1, 2, 3, 4, 5 beams. Okay, and number of nodes 1, 2, 3, 4, 5, 6. Okay, and now select nodes and go to translation repeat and select direction will be y and spacing will be 3 meter. Okay, and number of step will be 5. Okay, and then click link step, press OK. Okay, now we will create beam between these nodes. So go to geometry and go to beam, click add beam. Now create our beam. It will take some time. Okay, but we have one option for create this geometry. So click ESC and then go to select, click beam cursor. Now select your beam, click Control and then select your beam, click Ctrl+C and then Ctrl+V. Okay, so we will copy in Z direction में, spacing will be 3. Okay, press enter. Okay, now Ctrl+V. Now select and Ctrl+C and Ctrl+V. Okay, click Y direction, Z direction, distance will be 3. Press OK. Now then select, click Ctrl+C and Ctrl+V. Z direction will be 3. Okay. Now select option, click node cursor, select all nodes. Okay, go to geometry and go to translation repeat. Go to Y direction. Go click global direction will be Y, and default step spacing will be 3 meter. Okay, height of my building will be 3 meter. Okay, number of steps, because my building is plus G+4. Okay, my building is G+4. So we have 4 floors and 1 ground floor. Okay, this is my ground floor, and I want to create 4 floors. Okay, so default spacing will be 3 and number of steps will be 4. First 3 meter and second, first 3 meters height, second 3 meters and then 3 meters and then 3 meters. Click link step and then click OK. So total floor is first floor, second floor, third floor and then fourth floor, and this is my ground floor. Okay, now go to view and click front view, go to select, click node cursor, no, wrong, click beam cursor. Okay, and then select lower beam, go to geometry and go to translation repeat. Number of repeat will be 4. Okay, and if spacing will be 3. We don't link. Okay, direction will be Y and then click OK. So, and now we will create, this is my plinth level. Okay, this is my plinth level, and foundation, my distance between foundation to plinth level will, foundation slab to plinth level will be 1 meter. We can take 1 meter, otherwise 1.5 meter. Okay, you can, it is depend on you and your soil properties. Okay, then go to select. Now click node cursor and then select lower side nodes and then click geometry, click translation repeat, click Y direction, spacing will be minus 1.2, otherwise 1.5. We will take 1.5. Okay, and number of steps will be 1 and click link steps and then click OK. So there is my plinth beam, plinth columns, and this is my plinth beams, and this is my first floor beam and second floor, third floor and fourth floor beam. So and here we will have my foundation slab. Okay, so go to view and display wool structure. Okay, and now we will apply the properties and size of my beam. Go to property and create, select prismatic. My beam distance, maximum my beam distance will be 4 meter. My beam distance is 4 meter, and now we will go to calculator. Okay, my beam distance is 4 meter, so equivalent 4,000. Okay, 4,000 divided by 12, divided by 10 to 12. Okay, so we will divide by 10, equal to 400. So 400 will be the depth of my beam. 400 will be the depth of my beam. Okay, and my column dimension will be 400 to 300 meter mm, otherwise 300 to 300 mm. So we will use rectangular column. So we will provide it 300 mm by 300 mm column. Okay, select first rectangular and then dy equal to 0.3 and ZD equal to 0.3. Okay, this is my column dimension, and second is my beam dimension. So YD equal to 0.4 and it is equal to 0.25. Okay, then add. It is my beam. Okay, so select, go to select option, go to beam option and click parallel to X direction and parallel to Z direction. Okay, so my all beam will be select. Okay, my all beam selected, have select. So click rectangle, we have select rectangle 0.4 into 0.25. So it is my section property and it is my beam. Okay, now we will check assignment method assign to selected beam. Okay, click assign and click yes. So you can check our sections having a name R2, 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 R beams, R beam member. Okay, and now go to prismatic. First option, go to first rectangle 0.3 into 0.3. It is my column dimension. So select parallel to Y direction beam and apply assign to selected beam and then assign and then press OK. So this is my R1, 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 R1. Okay. So now we will create one other beam because you already know the dimension of plinth beam will be less as compared to other beam, first floor and second floor beam. Okay, it is depend on your which type of dimension you should take. Okay, so go to prismatic, create rectangular, and my dimension is YD equal to 0.25 into 0.25. So this is my plinth beam. Okay, go click add and then close. So we will select only plinth beam. Go to view, go to front view, select option, beam cursor. Okay, and then create a rectangle in this portion. So my plinth beam, select, go to view and go to wall structure. You can see this is my plinth beam that is showing in red color. Okay, and we already selected prismatic rectangular section 0.25 into 0.25, assign to selected beam and then assign press yes. Okay, so my property have done. Okay, second is material. My concrete material is concrete. It is already when you can check if I will right click and then edit, you can check material is concrete. So if you go to material, so your material will be concrete. Okay, now we will go to geometry. We will go to view and go to 3D rendering. Okay, now we will check my model. This is my model. Okay, my column is rectangular. My column is rectangular and my column is square and my beam is rectangular. Okay, beam is rectangular and column is square. Okay, you can check. Now close 3D rendering and go to specification. According to IS code, okay, if you want to design or building as a seismic analysis, and so you need to analyze as your concrete for some specifications. Go to beam, and there are torsion, offset, inactive properties. ये क्या है? Property reduction factor. So if you will design your concrete beam, if you want to analysis, so you need to decrease your reduction factor for cross sectional area. Honey, reduction factor. You need to apply reduction factor according to code IS 1893/2016. Okay, according your code, if you will design earthquake analysis, okay, but we will go only simple analysis, and we will assign only live load and dead load. Okay, other we will not focus on earthquake load. Okay, so go to support specification. It's not required in this condition. Specifications, we need to create one fixed support because my foundation will be fixed. Okay, so fix, click on fix and click on add. So my fixed support has created. Click select, go to view, go to front view, and go to select node cursor, and then create rectangle and select lower nodes. Okay, and then assign to selected node, click assign. So my foundation is created. Okay, you can see in 3D gold display, you can see this is my foundation. Okay, it is fixed. Okay, now go to loading and go to definitions. If you want to assign earthquake load and wind load, so you need to define your wind load and your seismic load, seismic definition and wind definition. But we will assign only live load and dead load. So we will create load cases detail. Okay, go to add. Okay, first is dead load and click DL. Go to add. Second is live load. Click IL, impose load. Okay, and then click right. So we have dead load and live load. Okay, okay. We want to create my slab. Okay, so we will create slab. Go to geometry, and this is my plate. Add some any plate. First go to view and go to front view. This is my plinth floor, so we will not create any slab on this portion, and the load of this slab will transfer directly to the soil. Okay, and soil have a already bearing capacity, but the load come on this slab. Which load come on this slab, honey, will transfer to the columns through beams, and this columns transfer to the foundation. So we will create only slab on this floor and then copy paste. Okay, now go to utility and go to structure tool and go to cut section. Okay, go to select to view, click OK, then select this portion. Okay, so other portion will be invisible, only this portion will visible. That portion is under the rectangular. Okay, go to view and click 3D view. We will create slab. Okay, so geometry, create beam. You have a option. You can create a full slab on this portion, and you can create a small slab of this portion. Okay, so this portion and this portion and this portion. Okay, this is my slab. Okay, go to ESC, go to select option, go to plate cursor, and then select my plate, geometry, my view, go to whole structure, create Control C and Control V. There are some problem. Click this slab, then Control C and Control V. Okay, Y direction 3 meter. The have just been created do not have any property assigned to them it. Okay, and now click this portion, Control C and Control V. Height will be 3 meter. And okay, 1 2 3. My last slab is Control C and Control V. Y direction will be 3 meter. Click on. Now select my beam. No, first go to properties, go to prismatic. Okay, and we need to create a slab. Okay, so we will create thickness. The thickness of my slab is 0.15. Okay, and then add plate, select plate and select, go to select option, go to plate cursor and then select this plate, click control, select this plate, select this plate and select this plate and assign to selected view and assign to view. Okay, and now we will go to view and go to 3D rendering. This is my floor. Okay, you can check. This is my building. Now go to material, go to specification. We need to create, first we will apply diaphragm, otherwise we will create a master node. Okay, we have two options. Okay, but if you create master node and go to diaphragm, the only use of diaphragm and master node is only for seismic analysis, because we need, for seismic analysis we need to create lump mass. So we will create lump mass, so we will fix all node as a rigid node, as a rigid body. So rigid body means if all nodes are will be rigid, so we will create a behavior like a lump mass. Okay, so it is your option, you can create, otherwise not necessary in the only live load and dead load condition. Okay, we will create dead load and live load. First is dead load. Dead load on is only for parapet load and wall loads. Okay, so go to add, which type of load you will apply on your structure, it's depend on you. Okay, and it is a requirement as a client requirement. So self weight, first need self weight. Y direction factor is -1, go to add, it is self weight of my building. Okay, second is member load. Member load member, there are different type of load in member load. First is uniform force, uniform movement, concentrated force, concentrated movement. I already explained this type of load in my YouTube channel. You can see my video, honey, how to assign load and which type of I already analysis and design a simple beam and continuous beam and rigid frame. So we have already applied this load at my beam on this in this video on that videos. Okay, so this is my beam and I went to apply that load, but what is the value of my that load? Okay, so go to calculator. Okay, total height of my building is 3000 and now we will minus 400 for my beam dimension equal to 2600. Okay, now multiply by 200 is my brick size. Okay, now multiply by 20 is my density of my brick. Okay, equal to this one. Now divided by 10 lakh because this is because we need to convert this into meter. We need to convert this into meter because my dimension will be mm, so we will need to create it into mm. Okay, so 10 into 10, okay, divided by this one equal to 10.4. So 10.4 is the UDL of my wall. Okay, so we will apply minus 10.4 kilonewton global y direction. Okay, click add. Now we will create it parapet load. Okay, so now go to calculator. You see all my parapet wall thickness is 100 mm. Okay, and height of my wall is nearest 900 mm, otherwise 1 meter, nearest 1 meter, so we will take 1 meter. Okay, so 1 multiply by 1000 equal to this one. Okay, and now multiply divided by 10 lakh. Okay, for converted in meter equal to 0.1. Now multiply by 20 equal to 2. So my parapet wall is 2 kilonewton per meter. Okay, click that load, click add, go to member load, uniform force equal to -2. Okay, click global y direction and then click add. Okay, now close. So we have wall load and parapet wall load. Okay, now we will create it one load of that load of my slab finishing. Okay, so finishing load the depends on height of my finishing and density of my finishing. Okay, if you go to IS code 875 part 2, you can take directly the finishing load will be equal to 1.5 kilonewton per meter square and 1 kilonewton per meter square. It depends on your finishing thickness and quality of finishings and layer of finishing. Okay, so now go to member load. No, go to floor load and area load. It depends on you which type of floor and area, both will work. Okay, so my area load is minus 1.5 kilonewton per meter square. Okay, and global y direction. It asks you will create a one-way distribution and two-way distribution. Because my slab is two-way, so load will apply two-way distribution. Okay, create add, now close. So I have my finishing load and parapet load and wall load and self weight of my structure. Now click impose load and go to add and go to floor load. Okay, your impose load will come under floor load and only kilonewton per meter square. For residential building, it will equal to for residential building it will equal to minus 2 kilonewton per meter square. Okay, global y direction, add, then close. Okay, you can check this load is so only plinth level. So we will edit this load. First you check where are you apply this load. Okay, first we will apply, it is my finishing load. Okay, and we will apply only third floor. Okay, and second floor and first floor. Okay, first floor finishing, because we will not apply this load on plinth level, because plinth level load will transfer to the soil directly. It will attach directly to the soil. Okay, we will apply only this portion, because this load is transferred to the columns, and this load, this portion and this portion, and there are, it is a the floor finishing load of the upper portion of the upper portion of your is equivalent 0.5 kilonewton per meter square. Okay, and 0.75 kilonewton per meter square. So we will add one floor load in that load. Okay, clear, add. Now go to floor load, and this will be equal to minus 0.75. Okay, so we will where are you apply? Okay, it depends you, because it in STAAD Pro, honey, it asks you that he कि where are you apply. Okay, where, कहाँ पर आपको अपना लोड लगाना है, which portion you want to apply and which portion you want apply. Okay, so there are, you can see there are given some range. Okay, so we will create range where are you apply your, honey, you want to apply your load. Okay, so my range is from this portion to मतलब कि this slab and this slab and this slab. Okay, for 1.5 kilonewton and it is 0.75 kilonewton, so we will apply only upper portion. My building height is 1.5 meter, this one 3 meter, 3 meter, 3 meter and 3 meter. So total height equal to 3 3 3 3. तो 3 चौक 12, 12 12 12 plus 1.5 is equal to 13.5. Okay, so we will apply y range equal to 13.5 or nearest 13. Okay, and maximum range equal to 14. So this range is between this line and this line. Okay, so now we will click add. So you can see command global y, there has some mistake, we will add it now. Okay, so my direction is global y, pressure is minus के 0.75, y range. Okay, define y range equal to minimum 13 meter and maximum 14 meter. 3 3 3 and 3. Okay, 3 3 6 3 9 10 और एक 3 3 6 3 9 3 12 12, और ये क्या है, ये नीचे की साइड हमने माइनस में किया था, सो हमारा ये वाला नोट क्या है, ये 0 0 वाला है. ओके, सो तो ये जो वाई डायरेक्शन हो जाएगी कितनी हो जाएगी, 3 3 3 3, सो टोटली 12. ओके, सो इट इज इक्वल टू 12 और 11. You can provide it 11 or 12. Okay, I will provide it 11. Now modify it, and now you can see this load is apply only this portion. Okay, similarly we will edit this load. ग्लोबल y डायरेक्शन में y रेंज इज फ्रॉम 3 to 9. Okay, so it is equal to 3 and is equal to 9. Okay, now modify. You can see this load is this one, blue line, blue load. Okay, if you click this one, so blue load showing this one, this one, this one. Okay, so similarly this is your imposed load. It is so only ground floor. Now go to edit, and then we will apply only this floor, this floor, this floor, this floors, upper 3 floors. Okay, so we will create upper 3 floor. So height is 0 to 3 to 9 meter. Okay, global y direction में modify. So it will show only 3 floor. Okay, it is showing only 3 floor, but upper fourth floor. Okay, my fourth floor have and any, it is fourth floor only for walking purpose, otherwise taking sunsets and cloth drying portions, otherwise which type of portion you will use. There are live load is live load will be less as compared to this floor. Okay, so upper portion having some less live load, but it depends on you. If you will create any purpose, and you can take any gym equipments, so you can apply large live load, but it's depend on you which type of load you want, what the quantity of your load. Okay, so go to live load, then add. Now go to floor load. We will apply only 1 kilonewton for ऐसे walking purpose. Okay, for cloth drying purpose. Okay, and height will be 11 to 13. Okay, sorry, इसको क्या करना है, इसको modify करके we will modify this one because we need to create minus symbol. Okay, we need to. Okay, now this direction is downward. Okay, you can check. Go to dead load, click self aid, go to assign to view, and then assign. Yes. Okay, now go to unit gravity load. We will this is the wall load, so we will apply only walls. Okay, so which walls? We will apply only walls. So we will select, go to view, go to select, go to parallel to x direction. Okay, we have another option for selecting. Go to view, go to first view, and go to select, go to node cursor, go to beam cursor, and now select this beam. Okay, because this beam having load of this wall and this wall, and this beam having load of this wall and this wall, and this beam having load of this wall and this wall, and this beam having load, but this load is transferred only through this beam and to the foundation, but there are having some soil, so load will be less, but we will apply total load. Okay, so first, okay, so we will select, go to which type of load you apply, select this one, and then select this one, and then select this one, and then select this one. Okay, assign to selected beam, and now assign. Yes, you can see this is your dead load of your wall. Okay, so now we will apply dead load of parapet wall. Click this one and select parapet wall, and now assign to selected view. Now assign. Okay, this is my parapet wall, but there are some mistake. Okay, so because my parapet wall is only outer wall. Okay, so it is very complicated, so we will delete of this load. Okay, and now add other load. Go to add, go to member load, and go to -2 is my parapet load, global y direction. Then add. Now close and go to view wool structure. We will select only outer beam. Okay, it is very complicated, so we will rotate. Now then rotate. Okay, and now there is some mistake because we will not click on this option. Select this option and select the beam, and now assign to selected view, then assign. Okay, my parapet wall will be assigned. Okay, you can see this is my all load. You can check. So my live load and dead load have done. Create. We will create some first analysis. We will create load combination. Okay. So load combination we will create load combination. It is depend on your code. Okay. There you can see this portion in loading. Primary load case, combination load case. We have primary load case, live load and dead load. Combination load case, we haven't any combination of load case, but we will apply. So first there is dead load factor load combination 3 and normal SRS and AB. So generally format A first is LI. LI जो तुम्हारा रहेगा लोड रहेगा फैक्टर यू नीड टू क्रिएट वन फैक्टर. ओके, AI and LI. LI is factor and AI is your, so my AI is factor and LI is your load. So factor is my 1.5 and live load equal to 1.5. ठीक है, where is 1.5. Okay, first load, this is my first load case. Okay, and second is dead load and live load. Factor is 1.2 and 1.2. Okay, now add, and third is dead load factor is 1 and live load factor is 1. Okay, so we have three load combination. You can create as a according to code. There are automatic load combination. You can create automatic load combination, but it is not necessary because this is best method as your choice, because क्योंकि you will decide it what is the value will increase of your dead load and live load. Okay, so go to analysis and design. First we check the model. Okay, so we will go to analysis. Okay, we will design. We will explain the design portion after analysis. So go to define command. Okay, and which type of result you want to see. Okay, which type of result you want to see. Perform analysis, which type of analysis you want to do. Okay, so perform analysis. Okay, so it is static check and print all, सभी को देखना है मोड से, both static load, we will select all option and go to add. Now go to assign. Is it already assigned? Okay. Where is okay. So now we will create run analysis. We will tick run analysis and tick save. Click save. There are 0 error and 0 warnings and 1 notes. Okay. View output file. We will see my message about floor. One way load. About floor, one way load and weights. It will explain about one way load and weights. So it is not necessary for me because my all slab is two way. Okay, understand? So now go to post processing. Select load combination. It is already selected. Range, view range, wool structure, property. We will select all option and result view. Go to enables, mode save, enable automatic scaling, click all portions and then apply and then okay. So you can check this is the deflection of my beam. Okay, and this portion view result, you can check this is deflection and this is displacement. Okay, both are similar. Okay, because displacement, you can see displacement in dynamic load condition like wind loads and earthquake load. Deflection, you can see deflection in all conditions. Okay, live load, dead load, earthquake load, wind load, both conditions. And utilization ratio, it is so on your design portion because there are beam stresses. Okay, you can see only beam stresses, which type of stress will come on your beam, and second is beam forces, which type of force come on your beam. Okay, and then third is graphs, which type of graph. This is a graph of your beam. It is a ground beam graph. Okay, you can click, you will click this beam, so you can see the graph of this beam. Okay, this is a beam graph. There are some deflections. Okay, and it is this is my, it is my doubt that because I think about this topic. Okay, I explain you. You can see this beam. Okay, this beam, what is, मतलब कि it is a continuous beam or it is a simply supported beam in one side or it is a cantilever beam. You can see this portion. Okay, there are some negative moments. Okay, there are some deflection. You can see this is deflected 0.599 mm. Okay, and this maximum bending moment आपका ये, it is moment about z axis. Z axis means this axis के about moment. So maximum is 0.935 and this 0.593. This support is this one and this support is this one. So you can see this portion, you can see this portion, there are no roller support. Okay, if there are roller support, so there will be zero. It is so in this point bending moment will be zero. Okay, but there are some value of bending moment. So you can see in your real building, in your real building structure, in your real conditions, you don't have any simply supported beam. Okay, you haven't any simply supported beam, and in this portion you can see there are some negative bending moment. Okay, so this is nearest continuous. Okay, this portion is nearest continuous. Okay, this is the Fy. Fy means shear force. This is your force. Okay, and now you can see beam graph bending moment. Honey, it is Fx force in extraction mein, and it is shear force and force. Okay, both are shown in the graph. You can check the graph of your building. Okay, so now but we will check the result of my beam. It is okay or not. It is, but only we will check analysis portion. We haven't any design. ना हमने कोई डिजाइन किया है, ना ही हमने कोई डिजाइन के लिए प्रॉपर्टीज दी है. ओके, ओनली इट इज डिपेंड ऑन यू. Both method of design of your structure. You can use Excel, you can use RCDC, okay, and you can use your software which like that STAAD Pro and ETAB. It is depend on you which type of software you want to use for design of your structure. Okay, so this is my beam stresses. Which type of stress will come on my beam? Okay, if my double click, if I will double click of this beam, you can see properties, loading, which type of load will went apply. Okay, and this is the shear bending, and this is deflection. Okay, this is a deflection, but I want to design my beam. So if I will design, so there are showing the steel of the percentage steel required, and there are so the percentage of steel we want to apply. Okay, for my beam. So go to analysis. Now go to analysis and go to analysis and design and click concrete design. Okay, select IS 456 code. Okay, and go to define parameter. Okay, first is bracing. So my structure is concrete structure. It is not required. Go to CLB and the clear cover of the outermost. It is enough for. It is 25 mm. It is enough for my beam. Okay. Now clear cover 3. Okay, it is enough. Okay. The distance from surface of the member to end of the outstanding main reinforcement. Okay, we will not change this portion, and this is be enough. Okay, it depends on you which type of clear cover and what is the value of your clear cover and what is the value of your any effective depth. This is my clear cover and effective depth, which type. It is depend on your code, and it is depend on you कि कितना क्लियर कवर आप देना चाहते हो. ओके, depth of cross sections to be used to beam design, because if you want to apply the depth of your beam, so the design of your beam, if you want, if you are going to design, honey, if you will go to design, so the depth of your beam will be equal to this one. If you not apply this value, so it will select the value of your beam that you will select the before analysis. Okay, you have to apply. It is e face distance of any section from the end node of beam to the perform shear check. Okay, it is related to earthquake. It is not required, and it is the member length factor about the y direction. It is equal to 1. Okay, it is right, and member length factor z direction, it is right. Okay, and perform shear check against perform analysis. We, if you want to kill, if you want, you can click 1. Okay, otherwise it is not necessary. Now go to FC. It is the compressive strength of my concrete. This is equal to 250. Okay, 25000 25,000, because I am using M25 grade of concrete. Okay, and go to Fman. It is related to steel. Okay, it is 500,000. Okay, because my steel grade is FE 500. There are 500,000. Okay, you can apply this value. You can after see from your code IS 456. Okay, maximum. It is the maximum size of the main reinforcement. Maximum size of the main reinforcement is 32 mm. Okay, and now maximum size of the secondary reinforcement, it is equal to 12. Okay, stop. This is 25. Okay, click add, and this is 500,000. Click add, and this is 5,000. Click add. Okay, you need to click add. Okay, it is 32. Click add, and this is 12. It is enough. Yeah, it is enough. It is enough. It is. Do not consider. Consider minimum eccentricity about the axis of the time. We can use IS 456. Close itna. Okay, add. Now F face do design beam for flexor. Add S face and E face. You flexor design. You want to design our beam in flexor. It depend you. Okay, don't necessary. All portion the factor which is column design member to be magnified. ये 1 रहेगा. रेशो percentage of longitudinal reinforcement is 4%. Okay, and tight column, spandrel column, which column, which type of reinforcement you want to provide, force here. Okay, and two-phase distribution about major axis, and two-phase distribution about which the longitudinal reinforcement in column about four phases. It is created four phases, but arrangement of reinforcement, it is depend on you. Okay, it is very important because there you if you go to if you if you will go any side, so you can see there are only two-phase reinforcement will provide. Okay, so two-phase distribution about major axis. Okay, about major axis two-phase distribution. Okay, it is go to add. Now spacing, distance. Okay. Now click, go to this one, assign to view, then assign, select this one, assign to view, assign fman. First is fck fman. Okay, assign to view, assign, go to assign to view, then assign, and now maximum honey bars dia to assign to view. Now assign, and method for method, which type of method. Okay, method 1, assign to view. Now assign. Okay, and concrete design. You can see this one, second phase distribution of the about major axis. So first go to select. Okay, and second go to parallel. So go to beam select, go to x direction, y direction, go to z direction. Okay, because I want to design my beams only phase only two phase. Okay, so I have already clicked on this one, assign to selected view, then assign, and concrete design. Okay, now which type of command you want to provide. Okay, design beam. Okay, design beam. First click add. Now design column, click add. Design slab, click add. Take off, click add. Now click design beam. Okay, parallel to x direction select, and select parallel to z direction. Assign to selected view. Now assign. Second is column, parallel to y direction. Assign to view. Sorry. Assign to selected name. Assign. Design. Go design element. Go to plate. Honey. Select all plate. Honey. Design element. Okay. Assign to selected view. Then assign. Okay. Now go to analysis and design, and go to okay. I have done all conditions and all parameter provided. I have provided all parameter. Okay, go to run analysis, save project. There are 0 error and 4 warnings. Which type of warnings? First, we will see which type of warning are showing. Okay, warning. Reinforcement percentage exists maximum limit. Okay, warning. Reinforcement percentage exists maximum limit. We will see about this portion. Okay, first warning is this one. Reinforcement exists the maximum limit. Okay, IS 456 limit state design column number 445. Okay, design result M25 FE length 150 meter and cross section is 300 mm into 300 mm, cover for 40 mm. Okay, it is a column. So we need to require increase the size of your plinth beam. Okay, you understand why your plinth columns size is greater than as above column size. Okay, and otherwise we will increase total column size. Okay, so go to where is result. This is post processing utility command output result. There are some warning. Okay, find result for warning total warning is 4. Okay, so we need only 4. There are column number this one. Okay, and 4456 and length is cross section and cover. Now go to IS 456 column 446. There are total area of reinforcement fully designed, and second is this one column 456 limit state. This is column 445. Go to column concrete design. Go to concrete design. Define minimum maximum ratio 4%. We will provide it 6% because the maximum limit of reinforcement you can apply 6% in columns. Okay, so go to add, then select, go to view, go to print view, and now select this portion only and assign to selected view. Now assign my foundation reinforcement. I have increased my foundation reinforcement. Okay, utility. Go to command file. Go to save model. Go to in the last of your command file. Okay, percentage you can see. Okay, FC this one. Reinforcement is this one. Percentage ratio is ratio. You will select this portion. Control X. Okay, and concrete takeoff, design element, design column, design beam, FRC this one, member one, maximum spacing. ये maximum. Click enter and then control V. Okay, now check. There are zero warning and 0 error. Now close. Okay, go to analysis and design, run analysis. There are zero error and zero warning. Okay, go to post processing and now done. Select all scaling for scaling automatically. Okay, now apply. Okay, so you can see, click yes because there are node selected. Click this one, so you can check geometry property loading share bending deflection and concrete design. You can check my column having reinforcement this portion, this is the cross sections of middle section, this is the cross section of outer left go right side corner, left side corner, and middle cross section. Okay, the width is this one, depth is this one, fck fy this is this one, and total number of bar 3 at the rate 10. Okay, and in this spacing. Okay, to this one, this is spacing tak. Okay, 2.3 meter. Okay, and there are 3 bar 10 diameter at the rate 365.00 spacing, 2 of itna. So you can check, this is not good for design purpose. So for design of your concrete structure, if you want to design your concrete structure, you need to go on excel and on you need to go excel and advanced concrete design rcdc. Okay, this portion will explain in my next video, and there are design have done. You can check the result